Okay, so I'm going to do a Intro to .NET Part 2. When you say new project, I'm just going to explain some of the project types that are in here. Now I've got a couple, these are all considered project templates. You can create these in Visual Studio. They're not that hard to create. I have some in here because of WPF and MVVM, but I'll show you the basic ones for C#. So you have a Windows Form application, and this basically opens you up into a app that has a form layout. So it has a screen and you have buttons and you can double click the buttons and you can add code. Many of you probably play around with .NET or C#. This is probably the one you've picked. You've seen it. It looks a lot like MFC without all the MFC macros. Pretty simple to use. That's a Windows Form. WPF is also the C# app. We won't get into that. I'll switch this one. This is a ribbon application, which just puts the ribbon at the top, which is the Office ribbon. Console application is just a console application command line thing. A class library is an assembly or a DLL that you create that you can then include into other projects. So you may have a class library for just your math routines, or a class library for just your mouse routines. Well, you really don't do that in .NET, but you get the idea. And then the other ones here are just all other applications I've installed. So we're going to look at a console app, and I'm going to talk to you a little bit about basic, your base containers in .NET. So the ones you're probably already aware of is I can create ints. And when you open up an int, there's a bunch. There's int 16, 32, 64. Those are, we'll do an int 32, x equals 3. An int 32 versus int 64, how many bits you're using for the int. Almost all of the class types or the object types in .NET are derived from object. So I can cast x as an object, and it works. So I say object y equals x as an object, and that'll work. It's a common ancestor to all of the variable types in .NET. So if you're ever passing stuff around and you want to be able to get to it and you don't know what they're passing you, if you cast it as an object or you put in your parameter, your method parameter as an object, everybody can convert to that and back to whatever they were. Alright, so we have an int, we have an object, we have floats, that works. We have also string, and a string is very much like a C string in MFC. That's kind of your basic, and we also, other than int32, you also have just an int. Int z equals, it's an int. Those are your base types. There's probably a couple more, but I think that is the ones that we use most of the time. Now, in addition to base types, they have collection types. And collection types is a way to hold array versions of these in an array. As you see right up here, I already have one right here. String bracket bracket args. What that means is this is an args array of type string. And I can create those down here too. So I can create an array of ints this way. I can say int bracket bracket x array equals a new, and it says, well, how many? So I can say, well, it's a new array of 3. So that just gives me an array of 3 ints. Using this bracket bracket notation is a way of creating a fixed size array. They don't grow. If you want to add another element to this one, you'd have to reallocate it again, and you can do that on the fly as it's running. You can new up a new one with a bit more. But instead of using these, a better thing to use is what they call collections. So I can use a thing called a list. And a list, you put a list in, it says what do you want, what's its type going to be. So I can say it's a list of type int called x array equals a new int. That is a little more wordy, but it's saying, give me a dynamic array of ints. And this array, I now can do xArray. If I hit dot on that, you see I have a whole bunch of new options. I have add, which will add one item, add range, which means I can add a collection of new items. So if I had another array of ints, I can say, boom, stick that whole thing in there. I have as read-only, so I can return a read-only version of it. I can do a binary search on it. I can check its capacity. I can clear it. I can check if it contains a certain int. I can copy. I get the count of it. It tells me how many items are in there. I can check if a certain integer exists. I can find next, find last next. So there's a whole bunch of cool things that we can use off an int. Now you might want to wonder, what's the difference between the bold stuff in here and the non-bold? The bold are actual methods off of this collection. The non-bold are what they call extensions. And I will go into extensions in another video. But we're just going to focus on the bold ones. So if I want to add something, I could say add a 5, and I could say add a 3, a 2, add a 1, and that works. And I can do a list of anything. So I can say a list of string. And I have the exact same stuff. So I can say list.add, and I can now say hello, and that adds my strings out. In addition to lists, I can do that for any of those base types, and also classes. So if I had a class, let's create a new one over here. So I'll insert class 1. I'll just leave it with that default there, and I can come back over here and I can say I want a list of type class 1, and I'm going to call these classes equals new list of class 1, and then I can say classes dot add a new class 1. So there's a list. Adding, removing is the same thing. I can just go in here and say xArray.remove, and I can say remove the 5, and it'll go remove the 5. I can say remove add, I think. Yeah, I can say remove add and remove the top index off of there, so I'll pop that one off. So there's a whole bunch of cool things you can do with these collections. In addition to a list collection, there also is a dictionary. And the difference between a dictionary is it has me, I can put a key value pair in there. So I can say, I want a dictionary of ints, and that's going to be my key. Actually, I have my key be a string, and my value to be ints. So it's key equals value. So I can say, then let's call this G equals a new. So now what that allows me to do is when I add stuff, I have to add it with a key and a value. So I say g.add, and it wants to know what the key is. Well, this key is age, and the value is going to be 3. And then you can do year 2011. And then you get at them by saying G bracket age has to be case sensitive equals 4, and that's me setting it. Or I can get it the same way. I can say, you know, print out to the screen G bracket age, and you get it. And you can do a dictionary of anything. Anything can be the key, anything can be the value. So I can have a key be a class, and that means whenever I pass it, I say, give me the value of this class. You pass the key as a class. The class has a value, so it uses the class's hash variable. So every class has a tag. So that class right there, class 1, may be, you know, hashtag 9,266,000. So it equals something. I can say class 1 equals a new class 1 will be false. And maybe that kind of confuses things, but anything can be a key, anything can be a value, and you can pull stuff out of it real quickly. So dictionaries are really cool. Another thing that I use, I think those are the two main collections I use, is a list and a dictionary. There's other ones that are hybrids of those that you can use. Like you can use an enumerable, which is a list derives from an IEnumerable. So if that's just going up one in the class hierarchy, you can get to an IEnumerable item type, but it basically is the same thing. You can get to a hybrid dictionary, which is a dictionary that has two different mechanisms inside of itself for when you have a lot of items versus a little items, how to find them the quickest. But those are the two main types you'll always use, is those two, list and dictionary. Now, how do you iterate over one of these? Well, it's pretty simple to just do a for each. In .NET, there's really these two that you use the most. A for is a for loop. That's where you say for x equals 0, as long as x is less than 9, then x plus plus. So it's very similar to C++ syntax. But most of the time in .NET, you use a for each because you don't have to go and create a variable from your index. It does that for you. So I can say, let's do list. So for each string, what was str in list, now I can do stuff. So I may say console.writeLine. I can just put str. And it'll write that string out. Boom, 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 boom. Every one of them that's in the list. You can do that with any of them. I can even do that with the dictionary. I could say change this list to G. But once I use G, it's going to want to know what. So I say G.values. And that will iterate each of the values. So that in this instance, it'll be each of the ints will come out of there as I for each to it. Or I can do for each over the G.keys. And I can spit out all the keys. So those work. Other cool stuff with the for eaches. I think that is the base. I don't want to go too long on this. So I've got your variables, types you can use there. We have collections and how to use those. And we have iterating over those collections. I think that'll be good for right now. Thank you much.